Thank you. Okay. I'm normally giving a demo of Declare, which is a little bit my baby, if you understand. But this time I will not give a demo. This time I will present something which is more closely related to my motivation, actually, to do model-driven development, software engineering, etc. And it's also more philosophically related. I'm a person that starts with hating processes. So if you say, do the questions at the end, I think that is over-specifying. I would like you to have questions all the time so that we communicate, because we are agents. We are not steps in a process. So things become over-specified very quickly and actually do not add any value. So that is one of the things that I want to give you. And I want to actually explain why that is and how we can go away from that, how we can enlighten ourselves, if you like. And that's an effort that we have to do together. So that's, I hope, I inspire you in that direction. Okay, so first some philosophical ideas about creating models. And creating models is something very generic. I mean, if I make a program, I always say creating a model. Yeah? If I do something which has specific meaning in some artificial language, which you can check whether it's consistent and whether it has a meaning or not, then in my sense it's a model. That's what I mean in model in this presentation. So, for example, we have somebody that produces a model in some artificial language using some abstractions in that language, like inheritance or something. And there is a user that uses that model. It could be a user of a program or somebody that validates the model or whatever, looks at it as a picture, tries to understand it. And there probably is a relation, hopefully, between the model and the user some way, otherwise it goes wrong anyway. But they all, the user, the modeler, and the one that creates the requirements or pays the bill, sometimes even, they all have their own perception of their own reality, their own world, either the reality that exists or the reality that has to be realized by this project or whatever, or a combination of those probably the latter. Yeah? So internally, they have also a model of it. Whether they are conscious or not, they create a model, so they don't see the reality. Nobody of us sees the reality. We only see our own interpretation of that reality, yeah? Which could be well mapped to that reality in some way. That's not, per definition, not the case. But this model also has some mapping to it, because this modeler has some notion of the reality, using some abstractions in its thinking, that he, consciously or not, used to create the model. Yeah? So, this is the context in which we do our work. Yeah? And there are a lot of errors in it. And most errors in software engineering and modeling is not a tooling issue, or whether it's on the web or not, or how fast your compiler is, or whether the tools integrate well or not. Most errors are actually because these implicit models and notion of the reality and the notion of reality which is produced by this modeler, they all deviate from each other. They actually do not understand each other. Or what is happening is that this explicit model, for example, a piece of software, is going to play a role in reality. It's going to influence how we think about the reality. Could be productive, could also be counterproductive. So we think that that's the reality. And we're going to act upon it. We're going to act in a stepway fashion, because otherwise we don't get paid from the insurers or something like that. Huh?
As Larry Lessig said, code is law. In this case, the code is implementing a model, an explicit model, and when you have code running in banks, government, etc., it's modifying
the world.
Exactly.
Oh, okay, so exactly. So this is what's happening. So this all circles around. So it's a kind of feedback like loop where are all kind of communications. This is the world that we're living in. And you need to be conscious of that. Because there the real mistakes are made. Yeah? So, now, what can we do about it? Because there are two aspects about it. One is communication. Yeah? So you have to really communicate about this. Right? So you have to acknowledge that there are different parties and you have to communicate with those different parties. And not one controlling the other, but really together. So there should be some process in developing models or DSLs or instances of DSLs that facilitate this structure, because otherwise you will never go to the correct model. You have to involve the different parties. The other one is you have to really think about which kind of abstractions you're actually using in this model. Of course, it could be that you use abstractions because just you understand it, or it's convenient, or it executes fast, or something like that, that actually pollute our thinking about the real world and actually introduce more problems than that they solve. Yeah? So this is something that I feel very strongly about, and I hope you too, at least now. Now, just some ideas from philosophy, for example. Each model or program is based on some implicit perception of the user domain. Yeah? So that's you need to be conscious of that and check it. The mapping of a model to reality can never be defined, because that would be a model. And you have to check whether that model maps to reality. So it's known. The relation to reality is something that only lives in the humans that share the same world, or even other species or agents or whatever. Using the right abstractions is essential, hence the right language to define your models. Try to use models that are precise, one-way interpretable, not over-specifying things which are not relevant to your domain. At the other end, be complete enough to grasp the minimal complexity of the world in which it has to be executed or meaningful. So not over, but also not under-specifying. So what kind of abstraction do you need for that? You have to think about that when you develop a DSL or select a modeling language. This is one I encounter a lot. An understandable model, you can create a very simple model which is understandable. For example, an example. Most people immediately grasp the example. But what they do is they project the example as the reality for all the examples, which is not the case. So understanding an example as a model, like a use case, for example, defining requirements in use cases, bad idea, because you only create some examples. That's it. You're not really defining the requirements in a formal way, not at all. So how do we know that a model is good enough? Roughly, I've learned that there are two kinds of abstractions, if you like. Declarative abstractions and imperative abstractions. If you look at systems, like let's take the type checking example that we have just encountered. Type checking and name resolutions are things that are intertwined. You can't go over that. All languages, object-oriented, they are intertwined. Which means if they do not have a common ground that's integrating them, some semantical underlying mechanism, it won't work. Because the type determines what the name means, and the name determines the type, etc. So, if you would have some imperative solution to type resolution, then it would be very difficult to integrate with another one that created another imperative specification of your name resolution. Because at some point they have to intertwine. So how can we create models that define exactly what you mean without over-specifying it, because otherwise, if you're over-specifying it, you have a problem in integrating these two models together. Yeah. So, non-integratable or badly integratable imperative specification. They are technical, artificial, data process. Where's the data in this room and where's the process in this room? Stupid idea. Model view control. Why control? It's a transformation. Why do we have to impose something that is in control? Because computers are like that? Because we feel safe? Because we think we are in control ourselves then? That's the way we understand the world. Less verifiable. They have the tendency to oversimplifying things. They are example-based. For example, in my, what I'm working on in the Netherlands is now a way to formalize protocols and guidelines for health industry. Thousands of guidelines, very complex. But in a hospital, they all have to be integrated. And currently, there are a lot of ICT people that say, well, you need to create care processes. So we have a care process for broken legs and a care process for breast cancer or for other diseases, high blood pressure. So there's some complaint. We have a measure of some kind. We do a diagnosis. We do a treatment, and hopefully there's a cure or something else. And then I say, well, this is not really reality. Oh, they say, no problem. We just create cure, and then if there's a complaint again, we do something, and then it's iterative. It's iterative. That's the solution. Yeah. It's not reality at all. We go to some doctor. We are worried about something. We want to go to a specialist that puts us at ease that we don't have that disease, which is completely different than a kind of complaint. It's a different starting point. If you look at it like this, then actually the measure or the diagnosis can have a completely different treatment in a different health path, for example. So what is now actually the context of this process? Who or what? Where it is defined? Are we going to make a data flow here? Which data is actually exchanged between those steps? How do we know which data is relevant? Is that defined somewhere? In a model or something? No. Let's first do the diagrams. This is a different way of thinking. We all know a kind of structure modeling, whether it's relational or fact-based modeling or object-oriented model, the structural aspect of it. For example, we could think of, but this already raises a lot of questions, which is a good thing. A patient has some diseases. We already know that it has high blood pressure. And the patient has medication for something. So there's some intervention, some treatment already in place. It has perhaps a complaint or a thing that happens to it or whatever. And indeed, there could be a diagnosis, but that is not a kind of process. It's something that takes this all into account and perhaps came to the conclusion that the disease that already existed is not actually the disease that the patient is suffering for, or that there need to be an additional disease, or the diagnosis is that it is cured. So it actually is a rule that defines the meaning of disease, when a disease occurs or is removed. And this you can actually define from those protocols. If you formalize all these different rules, and this is of course an oversimplification, but you can do that for all kinds of attributes and things. This way of thinking is the base of declare, by the way. You just have a model with arbitrary complexity, where you have to ask yourself, what are the multiplicities, what are your inheritance relationships, etc., and define the rules that derive certain aspects of the model. If you have a complete overview of that, then you can derive a zillion of things of it. You can actually derive the process. You know what you need to know, because the rule defines what you need to know to derive something. You can actually know what you don't have to know, because some things are not relevant in some cases. So you can optimize, per instance, how the process would look like, which questions are asked.
I find this diagram more complex than the previous one.
Yes.
And the previous one, that was oversimplified, right?
Yeah.
But I think it's only oversimplified if you use that model as like the template for what reality has to be. But if it's more like and ideally this is how the process goes, but it bears no real relevance to reality, then it's not an oversimplification, then it's just a simplification. And this one is much more accurate, obviously, but it's also more complex.
Correct. Correct. So here the problem is, you stated the real problem here. Because the most counter arguments that I get in a discussion is always, well, that's so difficult. It's difficult to understand, difficult to write. How do I define actually? Is there one caretaker that's doing an intervention or multiples? That kind of things. And I think if you don't ask those questions, if you don't define it, how the hell can you actually implement a system where you are confident of that it really works? So you have to counter for the minimum complexity. But I'm not ready with answering the question, by the way. But okay. Yeah.
Please.
Okay.
Follow with
Okay.
answering the question, and then.
Now this one is obviously written by me to prove my point. I'm guilty. But the problem is that in reality, this actually is refined to software. That the software in the health industry is built like this. So, again, creating a model that you understand is by no means a model that really works or has a positive meaning in real world. There is a minimal complexity in reality. Modeling is complex. Modeling is something that you need to learn, that you need to invest in. And if we don't do that, we create crap solutions. Yeah, so that's my answer to it. But I understand why this is simple if you just see it as an example, but not if you think this is a solution. Nico.
Maybe just one comment to this one. I think it's not so much of what you experience in real world, because that's the happy flow, right? And that's what most people think about it.
No, the happy flow is actually,
Yeah, I mean, like,
if I'm going to my customer, and there is no treatment at all.
of course,
That is the real happy flow.
In a process, people think about the happy flow, and then they come up with such diagrams,
Yeah,
and then you start asking, so what happens if the diagnosis is indecisive?
But eight of the 10 interviews in a hospital, there's no treatment. Still, all the standard processes involve the treatment. Yeah. So, thanks.
Now, when you come to your model, the next slide, the digital, I'm wondering.
This one?
Yeah, this one.
Yeah.
I'm wondering if this is not something we would do anyways, if we have somehow combined approaches between generative and interpretative approaches, because for being able to generate a system which is then able to hold these concepts, I would still do a class diagram and then define what the concepts are and how they are related to have something to store in a database, so without the rules maybe.
Yeah.
And then I have a class process model on top, which then gives more details, let's say, to these objects that I might have here. And to use these two things in combination basically then allows you to tailor the processes rather to what is happening in your real use cases, but you still have this anyway in the background because you need it to visualize.
I hopefully. Well, one thing that you said is when first we're going to create a class, first we're going to create the class model, then we're going to do the model, the rules.
Yeah.
So this is already on a meta level a simplification of the real world, because the rules actually, if you try to define the rules, you actually validate whether you have to create the right concepts and relations. So sometimes you need something as an input to actually decide whether it's a disease or not, for example, or not, the age of a patient. And then you have to add that attribute, because this is something that is required because of the knowledge that you're modeling. So there is no way that they are first one, then the other. It's iteratively completely developed. So it's an intertwined model. Also, even on the meta level, that's the case. But of course, you can create state machines. Of course, you can create processes. But they don't add any value if you have to do the other stuff anyhow. They only over-specify things which are irrelevant. And they have the tendency that they pollute your way of thinking about reality, because reality is much more complex than what you think is how it works. So I come to one conclusion. I think I always, oh yeah, the flat one is also a nice one. A process-oriented view on the world almost always assumes a kind of flat, there's a bunch of variables, but that's not the case. We have a history of a patient. It has different disease, different running treatments. So if you model it, and if you are aware of that, if you create rules that really take that complexity of reality into account, then you get solutions. Okay, a little bit out about how would we create such a language? Yeah. So declare is a way that is based on this kind of modeling. It's actually an engine in Java. But more importantly, it does not prescribe how it is executed. If you define this declarative specification, and you can even do that in a subset of Java or some modeling language at your flavor, then you can actually configure how it's executed. Is it reactively dynamic, which is nice for immediate performance of simple iterations, incremental performance? Is it functionally lazy? If you have to do a lot of bunch of execution, you can use the same specification. Why? Because you didn't over-specify it. And if you don't over-specify it, you can optimize for the different contexts of runtime. Yeah. One-off performance, functionally lazy evaluation, very fast. Incremental performance, reactive dynamic subscription, but your one-off performance is very low. Your footprint is higher. So this is just common knowledge. These are the questions that I try to answer. Of course, it would be ideal if we have something like this, but probably we need a kind of hybrid approach to solve this issue. So declare is about finding answers to how you can interpret those purely declarative specifications that encourage you to both not under-specifying and not over-specifying in a way in different contexts. Okay. It's a lot for half an hour, I think, but hopefully there are more questions.
Let's first thank the speaker. And then we have a couple of minutes for questions.
Nico.
Conceptually, I very much like the idea. From reality, I know both for myself, but also for customer projects, it's hard to come up with declarative languages, DSLs. And I think for at least two reasons. One is, I guess we're more used to, as programmers, we're more used to more imperative things, so they are closer to us. But also, in my experience, most people think more in examples which are the opposite, right? So, do you have any strategies?
No, we are just screwed. No, but this is actually a problem. Please realize that that is reality. What you're saying is reality. But the same reality causes the biggest problem. So the question is what we do as a community in model drivenness to make it more easy to do it, to educate people that that is the case. Not to neglect the fact that that's the case. I know that. I'm running into that on a daily basis. That's my only answer that I have.
Yeah, so referring to the question of what we can do, for example, to make this modeling more proper. So usually one would use this ontology, so how to model things and escape traps and modeling problems. And I've seen some companies like Semantic Arts providing consultancy services, ontologists that they can provide. For example, that join the project, see your a model, for example, and you fix it using some ontology methodology, for example.
Yeah, I'm with you. So the idea is that ontological approach could be helpful here. I think it is. I think it's still incomplete. I still, if you think like a semantical web or then they claim that they define the semantics, but actually they just do some typing. So it's and if they do some extra transformations like what I say, deriving a treatment, for example, then it's very limited. So they don't have really the power of doing complex transformations in that sense. They do mappings of things, so it helps, but it's kind of incomplete. And there is some artificial things like that. So what I see in healthcare is that there are different organizations that have different standards for interoperability and create ontologies for that. And they don't work based on those protocols. They just look at the world, at the current software, and they digest arbitrary choices there. Although we actually need to know the protocols and exactly the practice of medicines, which are applied in the Netherlands and complex, to actually make the right decision. We need to analyze that and formalize it. So, yes, it can help, but in the right way. Embed it into real knowledge of your domain.
Yeah, and I think the right way on the question, when is a model good or appropriate, I think from my point of view, the most important question is what is the objective of the model? And from that, when you know what are the users of the model, what are their concerns, then you can decide what is the appropriate level of abstraction.
Yeah.
Whether it should be declarative or imperative. If you're talking with a person who has no clue about hospitals, and you want to give him a glimpse, and even the clearly oversimplified diagram might be useful for that approach. Of course, it does not work when you want to implement the processes in a hospital.
Yeah.
But it depends on the objective of the model.
Yes, of course. But limiting the goal of a model is okay, because that's a choice. Can, and I see in practice a lot of times, and bear with me, I am agreeing with you. I'm just looking at practice, how it really works. So people tend to have a circle-like goal. You say, well, I want only type checking. Right. To teach you, yeah? Only type checking, no name resolution. And then in real life, it doesn't work because they are intertwined. No, I want only a knee operation, you know, meniscus. But if you take medicines for your bleeding, so that you not have plops in your bleed, you know the name. Then you have a problem if you have operation because you have you're bleeding to death. Yeah? So there are a lot of practical things in reality that you need to take into account because you're part of it. You need to know that. So yes, if you take that into account in this, what you're saying, yeah, of course, a model has a goal. And also readers. Could be that you have to explain the model for people that understand processes, and then you can give examples, of course. But don't think that you really have explained the model, because you only have given some examples, which is something different. Yeah? Fine.